Okay, so based on some of the responses, I'm going to go back and look at sensors again because the people that are doing it are messing up the sensors. Okay, so you should be able to recognize not only the devices within these, but also the function of the whole thing together, right? So the stuff that we covered before the lockdown, I'm just going to stick a new slide in here, was sensors. So the idea is that if you ever see a circuit with two resistors drawn, two resistive elements, it doesn't have to be resistors on its own, right? Right, so if you see a thing drawn like this, that circuit is called a voltage divider. It'll take too long, I'm just going to do it handwritten. Okay, so these things are called voltage dividers. I'm not happy with this pen here. These things are called voltage dividers. Sometimes they're called potential dividers. It'll be voltage or potential divider. Potential is just another way of saying voltage. Remember, potential difference. And potential divider or voltage divider. These are the circuits that we use to create sensors. How do we create sensors out of them? Well, what we do is we put transducers in there. And again, the transducers that I had introduced you to were the LDR, the light dependent resistor, the thermistor, and the potentiometer. So this is stuff that we did in school. Okay, you can also use switches as sensors. So there's single pole, single throw for on off, single pole, double throw for changeover, or double pole, double throw for reversing. And remember, you can get these switches as latching or non-latching. Okay. So the symbol that they seem to accept for a non-latching switch is that. The idea that's push to make. So you press that to close it, and as soon as you take your finger off, it would go back up like a doorbell. So those were the sensors. Those were the transducers that we could put into these circuits, and we had experimented with them already. So you should recognise that a voltage divider. I'm just going to copy and paste this because that would be much easier. A voltage divider that looks like that operates as obviously it's a temperature sensor, but in that configuration it's a hot sensor. What does that mean? What that means is the output is a high voltage out when the temperature is high. Shrink there, get them out of the way a wee bit. And if the circuit is created like this, then that's a cold sensor. So both of those are for temperature. They're both called temperature sensors. And this one detects hot, and this one detects cold. Something funny going on the tablet. And remember that this is always the output voltage here. This is always V out. The one from 0 to the middle of the voltage divider. Okay? So V out will be high when temperature is high. V out will be high when temperature is low, because it's a cold sensor. And then you can do the same for the light sensors. And you should recognise these, and you should recognise their operation. So if I do this for the light sensors, oh, that's not what I wanted to do. 1 and 2. And change the components, so that top one is now a light dependent resistor, an LDR, or in this one it's the bottom. So this one here is a light sensor. And this one here would operate as a darkness sensor. They're both light sensors though, eh? You know, they're both still called light sensors. in the same way that the other two were called temperature sensors. Just realised I haven't taken that over. These are both light sensors, and again the output voltage is still this voltage in the bottom half. Still V out. So in the light sensor, V out will be high when light is high, and in the dark sensor, V out will be high when the light is low. So when you're asked to describe these, you should always know, you should know straight away what one of these you're looking at. Because I've noticed that some people are making mistakes in the descriptions of the sensors. So group that, move that up there, shrink it a wee bit. So group this stuff here. Alright, so that's temperature and light. And then you could have a sensor that has a potentiometer in it. Now this is still a voltage divider because that wiper there just moves up and down. Okay, so in this position there's a lot of resistance in the top half and hardly any resistance in the bottom half. So it's still two resistances above and below the centre tap. Or you can put it up there, in that position, there's hardly any resistance on the top and a large resistance on the bottom. So again, this voltage will go up and down, V out will go up and down as the wiper goes up and down, as it is rotated. V out. So this is a position sensor. Or sorry, I'm going to rename that rotation sensor. Definitely something going on here. So that's a rotation sensor, and that's what that sensor would look like. Okay, written that one in red for no apparent reason. You normally draw it with the wiper right in the middle, the way I've drawn that one up there. You could then have position sensors, and they're just switches. All you're doing is wiring the switch up. So, you know, you would have again your VS and your V out, 0 volts, and you just have your switch wired like that. There you go. And you could call that V out of your position sensor, your switch sensor. So that will be either on or off. Yeah, so it's a switch sensor. And it could be used to detect linear motion or whatever. So that's all the sensors that we look at. Now you should be able to write proper descriptions of these. And you know, when I say proper description, I mean a description that fits a format, a description that hits the same points every single time, no matter what one you're talking about. Ultimately, you should always be talking about how to make V out high or low. Okay, so in this one, the user rotates the potentiometer, and V out will go up and down as it is rotated backwards and forwards. As the wiper goes up, V out goes up. As the wiper goes down, V out goes down. In this one, V out goes up if somebody presses the button. It goes off or down if somebody releases the button. So they should be easy enough to explain. These guys here are a little bit more involved. Okay, so I'm going to do this explanation of the hot sensor. So let's take that into another screen here, and I'm going to describe the hot sensor. Let's ungroup that and get rid of all the other stuff. Right, so we're only going to work on that. And let's do a description of the operation of this hot sensor, because you need to be able to get this right every single time. Okay, it's nice because we can just bullet point it. We've done this in the class before, right? So let's do it again. Type it so you can read it. So, as temp goes up, resistance of the thermistor goes down. That's the relationship's always the opposite way, okay? As resistance of the thermistor goes down, voltage across the thermistor goes down. They two are always the same way. So notice when we're doing our descriptions here, the relationship between the environmental variable and the resistance of the device is always opposite. One's going up, one's going down, or vice versa. So if you were to swap that to down, that would swap to up. Right, we've now got to, I'm pointing at the screen here as if you can see what I'm pointing at. So we've talked about temperature going up. Oop. Temp affecting the resistance of the thermistor, which goes down, and then in the second bullet point we've related the resistance of the thermistor to the voltage across the thermistor. Okay, we're not interested in the voltage across the thermistor, we're interested in the output voltage. We're always only interested in the output voltage. Okay, so as voltage across the thermistor goes down, V out goes up. So those two are always going to be opposite as well. If that one's going down, that one's going up. If that one's going up, that one's going down. And there you go, you've now got two arrows that explain the relationship between the environmental variable and V out. As temp goes up, V out goes up. You'll get a high V out for a high temp. That's what proves that this thing operates as a hot sensor. You get a high voltage out. It's on, the sensor is on when it's hot. It's a hot sensor. And that's like the last thing you would put out. So V out is high when temp is high. And I can't express this enough. It's always really, really important that the last thing you put in there is that expression of what happens. And this is the most important comparison to make. When V out is high, you always want that to be V out is high. Explain how this happens. Sorry, explain the input state. When V out is high. So that's how we explain the operation of a sensor. And you've already done it, but I'm going to ask you to do it again because people are still getting it wrong. So whenever you see a circuit that's got a sensor in it, where the question is explain the operation of the circuit, you'll have to have this. Now obviously, more recently we've talked about the fact that that guy in there will be a variable for sensitivity, so that would also make it into your description of the sensor. So like, you know, every single sensor that you see now, from nearly now, from this point going on, is going to have a variable resistor as the other one, alright? And that's there for sensitivity. I'll add that in just in case. I don't want anybody getting confused. Oh, wait, oh, what's happening? Where are you? The variable resistor is used to control the sensitivity of the sensor. Now, again, just a point to note, the whole thing is the sensor. The whole circuit is a sensor. This device here is a thermistor. That's a transducer. We use transducers inside voltage dividers to make sensors, and that's what's happening here. All 6 of these circuits are sensors. That's a thermistor, that's a light dependent resistor, that's a single pole, single throw switch. Those are components inside sensors. You need to be able to explain the operation of the sensors. Given that as an example, I want you to go ahead and fully explain the operation of all 6 of these sensors. I'm just going to stick that in. I expect to see the process that I've done on that other one copied. Okay, all 6 of those sensors, draw them out, explain their operation. Thank you.